Section 2.3, Creating Your First Knowledge Graph. We have covered the theory. Now let us build something. We are going to model a simple product catalog as a knowledge graph. This is a domain everyone understands, which makes it a great learning vehicle. We will create nodes, link them with relationships, and run queries against the result. Here is the domain model we will build. We have 4 node types: product, category, supplier, and customer. Each carries its own set of properties. A product has a SKU, a name, and a price. A supplier has a name, a country, and a rating. The relationships connect them. A product belongs to a category via in_category. A product is provided by a supplier via supplied_by. And a customer has bought products via the purchased relationship. Notice that even this simple model immediately enables queries that would require multiple join operations in a relational database. For example, find all customers who bought products from German suppliers in the electronics category. In a knowledge graph, that is a single 3-hop match pattern. On the right, you can see a visual representation of how these entities connect. This is exactly what you will see in Neo4j browser after we build it. Clickable nodes connected by labeled arrows. Let us walk through the 5 fundamental operations you need to build and maintain a knowledge graph. The first code block creates a product node with 3 properties: a SKU, a name, and a price. Run this in Neo4j browser and you will see the node appear in the visual canvas. The second block shows how to create a relationship. Note the pattern. First, we match both existing nodes, the product by its SKU and the category by its name. And then we create the relationship between them. We never create relationships without first having both nodes. The third block shows merge for safe upsert. It tries to find a supplier node with the name TechCorp Limited. If it does not exist, it creates it and sets the country and rating. If it does exist, it just updates the last seen date. This is the right pattern for loading data that may arrive more than once. The fourth block shows set for updating properties on existing nodes. You can set multiple properties in one statement. Use datetime to record when a record was last updated. This is good practice for any production graph. The fifth block shows deletion. DETACH DELETE removes a node along with all its relationships. You need detach because Neo4j will not let you delete a node that still has relationships attached to it, which protects graph integrity. Now let us query what we build. These 4 examples cover the query patterns you will use most frequently. The first finds all products under $500 ordered by price. Simple match, where, filter, order by. Exactly what you learned in section 2.2. The second counts products per category. Notice the aggregation. Count P counts the product nodes matched per category. This is the graph equivalent of group by, grouping by the category node and counting connected products. The third traverses a relationship to find all products supplied by a specific supplier. Notice how the relationship direction is reversed here. We start at the supplier and follow supplied_by backwards, using the left-pointing arrow pattern. The fourth is a 2-hop query. It finds all product categories that a specific customer has purchased from. This traverses 2 relationships. Purchased connects the customer to products, and in_category connects those products to categories. Distinct removes duplicates, since a customer may have bought multiple products in the same category. This is a query that would be complex in SQL, but is natural in Cypher.